Welcome to LearningQuEST two-part series on climate change. I'm Emily Northrop, the presenter today. I'm a retired environmental studies faculty and economics professor from Southwestern University in Georgetown, Texas. I'm a climate activist and I've given dozens of public presentations on climate change. So I was invited to speak in opposition to the views of Dr. John Christie, who's going to present on March 23rd. And I know that you viewers hold diverse views on climate, and I'm very happy to have that range of views listening in. So thank you very much for coming. Responding to the views of Dr. Christie presented me with some new challenges and learning opportunities. So I'm very excited and grateful to have been included. Lots of us were disappointed that the Zoom let us down when we were broadcasting from the library in Huntsville. So thanks again to the organizers for this opportunity to reach a wider audience. And I've added a little bit of info to address some of the specific questions that came up on Wednesday. So here's a rough outline. After some preliminaries, I'm going to present 6 significant points of agreement between the majority and minority camps on climate. And then I'll present 2 significant points of disagreement. After that, I'm going to address specific topics that today's organizers requested. Those were attribution science, people who dissent from the consensus science, why we need to take climate action, and what we should do. So to all who are already concerned about climate change, don't worry. Worrying does not help. Instead, be active. We need you to play a role. I'm going to conclude with some specific suggestions of actions that you can take, so have your pencils ready. To begin, I'll distinguish between climate and weather. Weather is what we experience when we step outdoors, the temperature. Is it rainy, cloudy, windy? Climate refers to long-term changes in averages, the weather averaged over several decades. So next, to distinguish between climate change and global warming, these are often used interchangeably, but NASA draws a distinction, and global warming is only one aspect of climate change. So global warming refers to the long-term warming of the planet, and there is a well-documented rise in global temperatures, most notably since the 1970s. And these maps are from an animation on NASA's webpage. As these pictures become more yellow and red, the Earth is getting warmer. This depicts the globe from 1880 until the present. And we've had about 1 degree centigrade, about 2 degrees Fahrenheit of warming since 1880. And that's relative to the average temperature in the mid-20th century. So that's global warming. As for climate change, these images are also from NASA. So according to NASA, climate change is global warming plus, and these pictures represent the broader evidence that are the consequences of global warming. A warming ocean, shrinking ice sheets, glacial retreat, decreased snow cover, sea level rise, Arctic sea ice, extreme weather events, and ocean acidification. On the webpage, you can see, on NASA's website, you can see that the scale of recent changes across the climate system as a whole and the present state of many aspects of the climate system are unprecedented over many centuries to many thousands of years. So here is NASA's statement of the majority view among climate scientists. Direct observations made on and above the Earth's surface show the planet's climate is significantly changing. NASA says human activities are the primary driver of those changes. And NASA goes on to say that most of the leading scientific organizations around the world have issued public statements endorsing this position. So NASA provides a partial list of those scientific organizations that agree with this. And here's a sampling from NASA's partial list: the American Association for the Advancement of Science, the American Meteorological Society, the American Geophysical Union, the US National Academy of Sciences, and the Geological Society of America. And in their words, the Geological Society of America, human activities, mainly greenhouse gas emissions, are the dominant cause of the rapid warming since the mid-1900s. So this is the NASA plus consensus on climate change. Here's another indication of how broad that NASA position is. This is a recent analysis of all the climate articles published by climate experts since 2012. So again, what percent of scientific studies since 2012 support the view that humans are causing climate change? Yes. Well, they found 99%. So more than 99%. The dissenters are still with us, but support for the dissent has shrunk. This scientific understanding is not new. This is an internal document from Exxon, 1982. And the Exxon said, the results of our research are in accord with the scientific consensus on the effect of increased atmospheric CO2 on climate. So isn't that interesting? Turning now to the dissenters. Prominent among the dissenters is Dr. John Christie. I say prominent, I learned about him before I recently moved back to Alabama. He is the state of Alabama's climatologist. And this is his recently published report, A Practical Guide for Climate Change in Alabama. So Dr. Christie has the ear of our state legislators. According to my state House member, Christie's is the only climate scientist that state legislators listen to. So even though he is such a minority view, he's the only one that has their ear. And I personally, I find fault with that. And here we are in Huntsville in a series this week and in 2 weeks, one session with me and one session with Dr. Christie. Arguably, the time should be split with 99% of it allotted to the consensus and 1% of the time on the dissent. So I politely offered that perspective to the organizers, both here and in a similar event that I participated in previously. One response to that suggestion of splitting the time 99% and 1% has been, science is not settled by a vote. Think of Galileo. Well, the suggestion for me to think about Galileo intrigued me, so I did. And what I found was a sharp contrast between Galileo's minority view and today's minority view on climate change. In a nutshell, Galileo was pointing forward to a new understanding. Today's dissenters are pointing backward to an outdated understanding. So I'm going to develop that contrast. In Galileo's time, the view that prevailed was from Aristotle. He believed that the planets and the sun orbited the earth. Then a Polish priest named Copernicus proposed that the earth was a planet like Venus or Saturn, and that all planets circled the sun. Later, I just had a glitch with my computer, sorry about that. Later, what Galileo observed through his telescope supported Copernicus. Copernicus and Galileo did not answer all of the important questions, like what is the shape of the Earth's orbit? How many planets are there? How do comets fit in? But more evidence accrued, the pieces fit together, and ultimately their view was accepted that the Earth and the planets revolve around the sun. So notice the minority view of Galileo pointed thinking away from the old into a new understanding. So turning to climate change, the orthodoxy was humans don't create fluctuations in the Earth's temperature. It's nature or God's in charge, but not humans. So the basis for challenging that established thinking. When did a scientist first measure the warming impact of carbon dioxide molecules? I always ask audiences this. Guess the decade that a scientist first measured the warming impact of carbon dioxide. And audiences are usually surprised to learn that it was the 50s, the 1850s. And this is before we were burning a lot of fossil fuels. So these folks weren't anticipating global warming, but Eunice Foote and John Tyndall did separately demonstrate that carbon dioxide and other greenhouse gases trapped heat. And that is a picture of Tyndall's lab setup. And let me insert, of course, if we had no greenhouse gases, the planet would have a frozen surface, much like Mars does. But it's possible to have too much of a good thing. And Venus has a humongous amount of CO2 in its atmosphere, and its surface is hot enough to melt lead. Next came a Swedish scientist, and he was the first person to calculate that the carbon dioxide humans are adding to the atmosphere could warm the planet. That the CO2 emitted when we burn coal, oil, and natural gas could act like a greenhouse and heat up the Earth. Then in 1960, Charles Keeling showed that CO2 was accumulating in the Earth's atmosphere. And that's when the pieces fell together. Carbon dioxide traps heat. Human emissions of CO2 is accumulating in the atmosphere. So the inevitable conclusion, human pollution is warming the Earth. So that's our new understanding. Humans are causing global warming. As with Copernicus and Galileo, not all the questions had been answered, but in both cases, the big picture came into focus. Right here, the big picture came into focus. So this is the moment of more apt analogy to Copernicus and Galileo. This, back in 1960, was when we had a minority of transformational, innovative thinkers who were pointing forward to the new understanding. If you want to put climate dissenters in the same category as Galileo, okay, but please don't overlook, just as Galileo did, these scientists challenged the old thinking and pointed forward to new thinking. Today's climate dissenters, oops, I messed myself up again. Okay, so I've done a few Zoom presentations, but I guess I can still mess it up. Keeling and the others were forward thinking, whereas today's climate dissenters are pointing backward, holding tight to an old, outdated orthodoxy. Since 1960, this new thinking has been extensively tested and explored, and Keeling himself made a critical ongoing contribution. I wonder if any of you have heard of the Keeling curve. Well, Keeling set up the first facility to provide a continuous measurement of the level of CO2 that accumulates in the atmosphere. CO2, carbon dioxide, is what scientists call a trace element, and it's measured over here on the vertical axis in parts per million. So if you take 1 million pieces of atmosphere, how many of those are CO2 molecules? When Keeling began measuring, out of 1 million parts of atmosphere, about 315 down here in the lower left about 315 out of 1 million parts of atmosphere were CO2. Today, that is at about 419. So please remember this number for later use. Humans have increased the level of CO2 by over 100 parts per million, from about 315 to nearly 420. 350 is highlighted in this graph. That's where we need to return the CO2 level to in order to stabilize the climate. So I want to agree that it is mind-blowing. It just does not make sense that a change in such a minuscule part of the atmosphere can change the climate. However, forgive me, but just because it doesn't make sense to me and you doesn't mean it isn't true. A different example altogether, it simply does not make sense to me that the table I'm sitting at is mostly space. It's flat out counterintuitive, but that's what the physicists tell us. So before I leave this slide, many of you know that carbon dioxide is not the only greenhouse gas that humans have added to the atmosphere. I'm focusing on CO2 due to the time constraint and because it is the principal global warming gas. If there's one image for you to take away from this presentation, maybe this is the one. Graphics often begin around 1880 because that's when we began burning enough fossil fuel to have an influence. The horizontal line, so 1880 till the present, the horizontal line at 0 represents the average global temperature for the 20th century. And so these blues represent years in which the global temperature was below that 20th century average, and the red are years in which the temperature is above the 20th century average. So there are ups and downs, but you can see the overall trend of the rising temperature. Now look at the black line. The black line is measured on the right vertical axis, and it represents the level of CO2 in the atmosphere. And you can see that the level of CO2 in the atmosphere has increased over those years, again, as we've burned more fossil fuels. We've known from the work of Foote and Tyndall that CO2 traps heat. We know from the measurements in the atmosphere with the Keeling's facility and now additional facilities around the world that CO2 has been accumulating in the atmosphere. And here's that relationship is borne out by the data. More CO2 in the atmosphere, a hotter planet. So here's a repeat of NASA's statement of the majority position, and human activities are the primary driver of changes in the climate. And while the majority, while the NASA Plus group agree on these main points, they are not on the same page on many of the important questions that remain. So as I shift now, well, likewise, I assume that the dissenters are not always on the same page about every point. But as I shift to 6 points where there is agreement between the majority view and the dissenters, I'm using Dr. Christie's views to represent the dissenters. And I'm doing that for 4 reasons. He is our state climatologist. He'll be speaking to you in about 2 weeks. He is widely recognized for his dissent. And I've got a reliable resource on his views. He lays out his position in his report, A Practical Guide to Climate Change in Alabama. So point number 1 of agreement. There is an enormous amount that we do not know about the climate. NASA groups agree that humans are driving climate change, but beyond that, there's a lot of important unknowns. One very significant thing we don't know is how global warming may occur more quickly and irreversibly than we currently understand. Just one example of a feedback loop. that we can't yet accurately quantify. So as you know, global warming melts the Arctic ice and other ice sheets around the globe. That leaves less white ice to reflect sunlight back into space, and more dark ocean and land to absorb heat. That gives us additional warming. This additional warming means even less ice to reflect sunlight and additional dark surface to absorb heat, which gives us more warming. How quickly this feedback loop works is just one of the many unknowns that could make our situation far worse than we currently know it to be. A second point of agreement, there is natural variability in the climate. So I've cited page 2 in Christie's report, but this is a principal and repeated point that Dr. Christie makes. As for NASA includes information about its about the natural variability in the climate on its webpage. Occasionally, an audience member has heard of the Milenkovic Cycles. These were named after the scientist who devoted his life to figuring them out, and he did his work about a century ago. These Milenkovic cycles produce variations in the amount of solar energy that reaches the Earth, and they are responsible for beginning and ending our planet's ice ages. So you can Google NASA and Milenkovic cycle to see some great animations. I just took some pictures. One of the cycles is because the shape of the Earth's orbit around the sun becomes rounder and then more oval. A second cycle is that the tilt of the Earth changes from more vertical to less vertical. And a third cycle is that there's a wobble in the rotation of the Earth. So again, these together change the amount of sun that reaches the Earth. And here are the consequences. You can see the natural cycles. So here, the horizontal axis is 800,000 years and until today. The vertical axis is the carbon dioxide level in the atmosphere. Again, that trace element, minuscule element, measured in parts per million. And when the Milenkovic cycles combine to warm the Earth, the extra heat releases CO2 from the oceans. So what I'm doing now is explaining why they put CO2 on this vertical axis and how that's connected to these cycles. So when more sun, extra heat, reaches the Earth, the extra heat releases CO2 from oceans, and this causes more warming in the atmosphere, which releases more CO2 from the oceans and more warming of the atmosphere. So this self-reinforcing cycle continues until the Milenkovic cycles reduce the amount of solar energy reaching the Earth. And then the process reverses and reduces the amount of CO2 in the atmosphere. So these are natural fluctuations in CO2 in the atmosphere, and they correspond to periods of higher and lower global average temperature. So the cycles in CO2 across 800,000 years are correlated with cycles in our temperature. So this top graph is the temperature, global temperature, with ups and downs corresponding to the ups and downs in the CO2 level. And again, these cycles in temperature coincide with the onset and ending of our ice ages. So a change in the CO2 level from about 100 parts per million to excuse me, a change in the CO2 level of about 100 parts per million has moved us through the ice ages. So can a change in the tiny trace amount of CO2 in the atmosphere change the climate? Yes, a change in the trace amount of CO2 in the atmosphere has had a big impact on climate. So I wonder if you remember from the Keeling curve how much humans have increased CO2 by about the same amount. And that is the spike in CO2 that you see on the far right of the graph. This spike that coincides with humans burning fossil fuels and pumping CO2 into the atmosphere, this change in CO2 is about the same size as the change in CO2 that is the consequence of the Milenkovic cycles. And so does this spike look natural to you? That does not look like part of the natural variation in CO2. So when I first saw these graphs, I wondered how come the temperatures hadn't shot up way more than they have. And the answer I got is that there is a lot of inertia in the climate system. Just like we cannot turn an aircraft carrier on a dime, the change in the climate is not instantaneous. So this is also why climate scientists are so concerned that the temperatures are going to catch up to this spike in CO2. A change in CO2 of this magnitude has moved us in and out of ice ages. So now that we've got a change in that magnitude here, how much warming is coming? I'd like to make another critical point about inertia in the climate system. As my US congressman likes to say, if we cut our emissions today to zero, it would not halt global warming. This is true, so I'm going to say it again. If we cut our emissions today to zero, it would not halt global warming. Due to inertia in the climate system, there is already additional warming baked in. So what's at stake is not the next few decades. We will get more warming. But what happens roughly after 2050? How much more additional warming will we get then? So we need to cut emissions now to protect the climate, humans, and other living beings in those out years. So on Wednesday, someone in the audience asked, how do scientists know the CO2 levels and the temperature levels from over 800,000 years ago? And somebody else in the audience knew that it's by analyzing ice cores. So scientists drill out a core of ice, and these ice cores are made up of compressed snow that has trapped air bubbles laid down year after year. And so they provide records of past temperatures. The longest ice core was in Antarctica, and it was 2 miles long. So they, by analyzing the snow of 800,000 years ago, we're confident in the CO2 level and temperature levels over that history. Okay. Just by the way, I missed the audience. I wish you were here, but here we go. So another point of agreement between NASA and Dr. Christie is there is a current global pattern of warming. Dr. Christie wrote, worldwide values were coolest in the 19th century and warmest today. So on this graph, again, from 1880 to the present, the 0 represents the global average temperatures for the 1950s, 60s, and 70s. And again, the blue represents individual years that were cooler than the average. and the orange and the red are years that are hotter than average. There are ups and downs in the temperature, but the trend is toward warming. 2021 tied 2018 for the hottest year on record, and it looks like the last 8 years were the hottest on record. The last decade was the warmest decade on record. A fourth point of agreement, extra greenhouse gases have a warming influence. I was very happy that Dr. Christie agreed with that. This again shows the global temperature has increased along with carbon dioxide. A fifth point of agreement is that Alabama did not follow the global pattern. Here is the now familiar graph of global warming since 1880. So this is for the planet as a whole, increasing temperatures. This is a graph from NOAA, the people who track our hurricanes for us. And for the United States as a whole, 1895 to the present. So this is US average temperature, and it has followed the trend of warming. This is also from NOAA, and this is just the Alabama temperature since 1895. And I was really interested to and fascinated to see that the Alabama temperature over this period has been essentially flat. Across the years as a whole, Alabama has not warmed. And it's not just Alabama. Actually, the southeast of the United States did not warm from 1895 to the present. And that has prompted a lot of research. Why is the US Southeast an anomaly to the global pattern? For what it's worth, this shows, this is again a repeat of the Alabama temperatures. And you can see that since the late 1950s, Alabama has adopted the global pattern of warming. And I didn't draw it in, but in these years, the 1920s, 1930s, 1940s, Alabama was actually getting colder. So we had a period of temperature declines followed by a period of temperature increases. But these colder years were what gave many of us cold football games on Friday nights that we remember as kids. So yes, Alabama is an anomaly, and that was not intended to elicit a laugh. But when I said that in the library on Wednesday, many people chuckled. But Alabama is an anomaly. A final and very significant point of agreement between the NASA Plus position and Dr. Christie is that we need to protect Alabama from extreme weather. Dr. Christie writes, Alabama has experienced tremendous extremes in weather variables, and we should do our best to prepare for these extremes because they are virtually certain to occur again and with a high probability that they will be worse, he says, with or without the influence of extra greenhouse gases. Unfortunately, we are very far behind in protecting ourselves from the emerging climate. Here's a headline from last year: climate change is harming the planet faster than we can adapt. So we're behind in adapting ourselves to the evolving hotter world. Just to give you a sense, adaptation measures range from water conservation and building seawalls to improving our health care system and planning for climate migrants. So we need to get busy really fast. So we have 6 points of agreement. Yay. Now I'll turn to the points where Dr. Christie dissents from NASA and the other scientific organizations. He writes, the impact of one tiny component extra CO2 is murky. And he writes, natural variability makes it difficult to determine the impact of extra greenhouse gases on the climate system. So look again at the record over the last 800,000 years and how movement in and out of the ice ages go in tandem with small changes in the tiny trace amount of CO2 in the atmosphere. A change of just around 110 parts per million. A change of around just 110 parts per million has moved us in and out of ice ages. And look again at how the global temperatures rise as human emissions of CO2 increased. Again, a small change in the tiny trace level of CO2. So this top left, so the numbers suggest, the numbers point to how a change in the trace amount of CO2 in the atmosphere does in fact impact the temperature and the climate. The top left graphs show 800,000 years, and this bottom right graph shows 130 years. So now I'm going to look at an intermediate time frame, something between 130 years and 800,000 years. And this slide shows the global temperatures over the past 11,300 years. This is a significant time period because it roughly is the range of human civilization. 2,000 years ago, Jesus walked the earth. I asked the audience the trivia question, does anyone know the oldest town on earth? And someone told the group, ancient Jericho. So Jericho is about 9,000 years old. Humans began agriculture about 10,000 years. So this is the picture of the temperature during the formation of human civilization. And the purple line is the best estimate of what the temperature has been across human civilization. And it shows temperatures relative to the 1960s, 70s, and 80s. Relative to the longer history, this is not much variation in temperature. This is recognized to be a period on Earth of a stable climate. Until just recently, when there's been a spike in global temps. And that you see that spike in global temperatures on the far right. This spike is taking temperatures higher than they've been across human civilization. So today is not the hottest the Earth has ever been, but it is the hottest since the dawn of human civilization, and it's getting hotter. You've probably heard people say that climate change is an existential threat. This is what some of them are thinking, that we are losing the climate in which human civilization formed and to which human civilization is adapted. This makes climate change a huge threat to human civilization as we know it. That spike in temperature corresponds to the Industrial Revolution and our burning of fossil fuels. Does that spike in temperature look like a natural fluctuation to you? And looking again at the Milenkovic graph, does this spike in CO2 look like a natural fluctuation? Well, not to my eyeballs, but let me be quick to say, climate scientists do much better than eyeballing data like this. They build complex models of how the climate system works. And this brings me to Dr. Christie's second point of dissent, the reliability of climate models. Clearly, if he found the climate models reliable, he would not be a climate dissenter. So I want to say a few words about models, since it's so key to his position. Models are widely used across scientific fields, and there are numerous teams that have developed their own climate models. And actually, they're sort of in competition to build the best model. They model what's going on in separate cubes and how the weather in each cube affects the weather in its neighbors. Each model is made up of equations that represent the laws of physics and chemistry. They account for variables like wind speed and direction, air pressure, humidity, how heat is absorbed by land and oceans. They also account for natural variation, and they include the impact of human greenhouse gas emissions. It takes really, really powerful computers to run these models. So how do they test a climate model? The test for how good a model is by how well it replicates the past. It answers the question, how would the global temperature have changed if the planet worked like the model? And here's an illustration of results that models have provided. The horizontal axis is the year since 1850. The vertical axis is the changes in global temperature. The black line shows the actual temperature history that we have observed. So that's what the models want to replicate. That's the goal. If they can replicate the past, then the model is good at representing how the climate works. What their models have come up with is the dark brown line. And so they want their results on the brown line to get as close to the black line of observed values as possible. When their results are distant, when the brown line is distant from the actual observations, they adjust the model. For example, they think again about how much heat the oceans absorb, and then they rewrite the equations to represent their new thinking. If the brown estimates get closer to the black observed values, then they've improved their model. They are better at replicating the past. They are better at modeling the climate. As Dr. Christie writes, the models were essentially made to agree with the surface temperature record. Modelers call that improving our models. And as our models are improved, we can better rely on them to predict the future, to forecast future temperatures. And you can easily imagine where the models say we're headed, that temperatures are going to continue to rise. Okay, so what's going on with the blue? The blue line also represents some model results, and you can see these blue values are very distant from the observed values. So these blue values are from a bad model. Well, what about those blue models? When they ran the models to get these results, they had removed all of the human influences. That is, they took out the variables that represent the impact of humans, like human greenhouse gas pollution. And you can see that if the human emissions are left out of the models fail to replicate the actual history that you see in the black. If they leave out the greenhouse gas emissions, the models are way off and not reliable. So I find this to be a very powerful image, that the models are lousy when they leave out human influences. So on Wednesday in the library, there was a good exchange around this. So I'm going to add an analogy and reiterate. So the analogy, let's say some engineers are designing a rocket, and they start with the laws of physics and chemistry, but if the rocket doesn't fly, then they think again and make adjustments. So is that a contrivance just to make the rocket fly? Or were they taking what they've learned and improving the rocket? Well, that's what the climate modelers do. If their models don't replicate the past, then they know they have not captured how the climate works. So they think again and make adjustments. The goal is to understand how the climate works. The test of the model is how well it replicates past temperatures. Is it just contriving the results to fit the past? Modelers say this is improving the models. And the improved models forecast, we've got some dangerous increases in temperatures coming our way. So another just really quick comment on what I understand Dr. Christie's second criticism of models to be. I understand him to criticize the models because they do not replicate Alabama's temperature history. Well, should we expect them to? There are regional variations in the climate. And as we saw before, Alabama has not followed the global temperature pattern. So what is NASA's take on the reliability of models? This is a recent study that NASA endorsed by putting it up on the NASA webpage. And in the interest of study confirms climate models are getting future warming projections right. In the interest of time, I'm just showing you part of the graph that was in this study. And what the study did was to check on how well past forecasts have been. What's the track record of past forecast? So back in 2004, modelers forecast what would happen to the global temperatures. Their forecasts, their results are in the black line. So the black is their 2004 prediction for what global temperatures were going to do. The red shows what actual global temperatures were. So yes, they anticipated the warming that the Earth experienced. NASA has endorsed this as evidence that the models are reliable. So a review of the areas of agreement and disagreement. Areas of agreement, a lot we don't know, including that it could be worse than we think it is. There is natural variability in the climate. There is a current global pattern of warming. Extra greenhouse gases have a warming influence. Alabama did not follow the global pattern, and we need to protect Alabama from extreme weather. Yes, and I confused myself there for a moment. And then the areas of disagreement, the role of humans versus nature. So looking again at this picture, if we take the human emissions out, the global temperatures don't rise. And the second point of dissent from Christie is the reliability of climate models. Again, if we take humans out, the models do not replicate the rising global temperatures that we've observed. So this is a good moment to hit pause and take stock and reflect before I address some specific topics that I was asked to talk about. So I was asked to address attribution. The NASA Plus position is that global warming is creating more extreme weather events, but we all agree that there's a lot of natural variation in the system. So when there's an extreme weather event somewhere, how big a role did human-induced climate change play in that specific weather event? Was the particular event more likely to have occurred or more severe because humans warmed the planet? The World Weather Attribution Initiative is a collection of scientists, a collaboration of scientists around the world who use the climate models to analyze extreme events right after they occur. So they want to figure out to what extent the specific extreme weather was caused by humans. And what they do is assess whether and to what extent human-induced climate change played a role in the magnitude and frequency of extreme weather events. So I'm going to give you the range of what their findings are. One disaster they studied was October 2020. Vietnam had some really heavy rain. It killed 138 people, submerged 375,000 homes, destroyed over 100 square miles of crop, killed 2.6 million cows and chickens. However, when they ran the climate models, they concluded that human-caused climate change was not the explanation. This weather tragedy was within the range of natural variation. Another example along those lines, factors other than climate change were the main drivers of food insecurity in southern Madagascar. But sometimes they conclude that it is due to climate change. Heavy rainfall, which led to severe flooding in Western Europe, made more likely by climate change. And one more example, last June, the Pacific Northwest had temperatures higher than ever previously recorded in the region. Portland, Oregon set a record on June 26 of 108 degrees. That was an all-time record until the next day when it was 112 degrees, which was an all-time record until the next day when Portland had 116 degrees. This heat wave had caused an extra 600 deaths. And these are 600 people dying from a heat wave in rich countries. Think how less equipped poor countries are to deal with heat waves. So the attribution scientists went to work, and their finding was that even in our current climate that humans have heated up, this was an extremely rare event. This is a 1 in 1,000 year heat wave, even in the world that we're in today, heated up by humans. If human global warming had not been around, then it is virtually impossible that this event would have occurred, according to the attribution scientist. That is, if we had not heated the earth, the odds were more like 1 in a million for this to have happened. So given those long odds, 1 in a million in a world without human-induced climate change led them to conclude that it would have been virtually impossible without human emissions. And they warn us that if we keep on warming the earth, by 2040, a heat wave like this in the Pacific Northwest could become as frequent as every 8 years, and it would be even hotter. So that's what I've got for you on attribution science. I was asked to address why some people doubt or dismiss the NASA Plus position. And this is my first of 3 slides on this topic. This is one article in the literature about how fossil fuel companies played an important role in creating public doubt about climate science, even though they knew better. Again, the excerpt from a 1982 Exxon internal document. The results of our research are in accord with the scientific consensus on the effect of increased atmospheric CO2 in the atmosphere. Oil companies withheld this information from the public and from their stockholders, and they backed organizations that encourage doubt. Here is a public ad from an electricity trade group. If the earth is getting warmer, why is Kentucky getting colder? And another ad, the most serious problem with catastrophic global warming is it might not be true. So they were aiming to instill public doubt about human-caused climate change. And this is decades after oil companies knew better. These people wanted us to doubt the climate science, otherwise their financial interest would have been hurt. Public attitudes about climate change has been the focus of academic study, and this little book presents several reasons that some people distrust the NASA Plus position. So regardless of where you are in your thoughts about climate change, see how these affect your thinking about this and other issues. So in the case of climate, there's a distrust of the message. For some people, it is just too far-fetched that humans changing the Earth's climate simply isn't going to happen. For others, it violates their religious beliefs that God is in charge. People are not in control. Another reason for doubt about the NASA Plus position is the distrust of the messengers. For whatever reason, you think environmentalists or Democrats or scientists or universities can't be trusted. And by the way, I'm hoping that a Huntsville audience finds NASA to be a trusted messenger. I am not asking you to trust me, a retired economics professor, but I've included a lot of NASA logos on images that I took from NASA's webpage, and hoping that you find NASA to be a trusted messenger. Distrust of the solutions. Some people just do not like the idea that we're going to have to work together through government to address climate change. And this brings up motivated reasoning. We tend to find information and reach conclusions to support what we already believe. And finally, cognitive filters. Our brains are filters, and they tend to filter in information from groups we identify with: our family, coworkers, friends, members of our civic and social clubs, our churches, those who share our economic interests. So those cognitive filters reinforce our connection with those groups. So it's all of these and the dishonest efforts of fossil fuel companies that give some people a dismissive attitude about climate change. So I was asked to make the case for stabilizing the climate, and I've got 7 slides on this. People often express huge concern about the cost of taking action on climate, but there are huge costs of failing to act, of letting climate change evolve unabated. Here's what's coming according to the NASA page. Change will continue through this century. Temperatures will continue to rise. The frost-free season and growing season will lengthen. Changes in precipitation patterns, more droughts and heat waves. Hurricanes will become stronger and more intense. The sea level will rise by 1 to 8 feet by 2100. Arctic likely to become ice-free by mid-century. And of course, the extent to which any of these happen has to do with whether or not and how much we cut our emissions. So globally, about 3.5 billion people are vulnerable to climate change. And here and around the world, the poor people are more vulnerable. Think of the people left behind during Hurricane Katrina in New Orleans. It was poor folks. And those of us who are concerned about poor people, we need to stabilize the climate because they are more vulnerable. Specifically in the Southeast, sea level rise poses widespread and continuing threats to the region's economy and environment. Extreme heat will affect health, energy, and agriculture, and more. Decreased water availability will have economic and environmental impacts. Climate change also increases the risk to other species. A high proportion of species is vulnerable to climate change. Maybe over 50% will become extinct if we don't do anything about the climate. These are 2 species who spend part of their time in Alabama and who are already endangered: sea turtles and whooping cranes. The Department of Defense says that climate change drives instability and is a threat multiplier. For example, an extreme drought is thought to have played a role in the start of the Syrian civil war. And we already have climate refugees, and we know that we're going to have millions more. This migration can destabilize the nations of origin, the nation the refugees travel through, and the places they end up. when persistent drought or sea level rise make it impossible to grow food, people are going to move. And this is already happening. Some estimate that between now and 2050, 30 million more people will aim for the United States if we don't get a handle on the climate. While there are winners and losers in an economic sense, on balance, climate change will hurt the global economy and the US economy. So this study anticipates that the global economy will be 23% smaller than in a world without warming. The National Climate Assessment Group says that global warming could knock hundreds of billions of dollars off the American economy by the century's end. This is a study that did a county by county analysis where they put together the economies of the county and the climate risk of the counties, and found that all of the counties in red are going to be hurt, economically hurt by climate change. The counties in green are going to be helped by climate change. So again, winners and losers, but on balance, the nation as a whole will take a hit from climate change. And as you know, it's the Southeast that is the poor region of the United States. And so as it plays out like this, it's going to exacerbate the inequality, where those that are already behind will fall further behind in an economic sense. So no study has demonstrated that COVID was caused by climate change, but this study does show the possible role of climate change in the emergence of COVID. And so this is just to illustrate the important point. There's concern that and recognition that if the climate change unfolds, if global warming unfolds as forecast, then there's going to be direct health effects for humans. So in this instance, climate change means more bat species. It expands the range in which bats live. And that means more coronaviruses because bats have them. And then that means greater chances for transmission to humans. So again, this study does not prove that. This study is suggestive. Another thing along those lines is that warming is going to extend the range of mosquitoes, and mosquitoes bring along infectious diseases with them. So that's expected. Last and certainly not least are the positive impacts of taking climate action. A recent study out of Stanford University did a state-by-state analysis on moving to clean energy, and it would have tremendous benefits. The study includes Alabama alone, and we would gain a net 240,000 jobs. Think of all those solar rooftop solar panels that would be installed, the opportunity for offshore wind energy. So we'd lose some jobs, but on balance, we would gain 240,000 jobs, according to this study. It would add billions to the state economy. It would save lives. Dirty air kills people. And again, it's more likely the poor people who live in the vicinity of a coal-fired power plant. So in 2050, that number will have grown to 770 a year. So it's healthier to have clean air, and it will cut our energy cost to nearly half in 2050. All right, so what to do? I have done 30-minute presentations just on this slide, and this is a group called Project Drawdown. So I'm just gonna do a quick bit on it, but I want you to see that we already have 80 proven ways to stabilize the climate. Every one of these solutions is already in use somewhere in the world. And together they would vastly reduce our emissions, and they would draw down CO2 out of the atmosphere. These solutions go way beyond just clean energy. Agriculture and land use practices and our diets figure in prominently. So the point is, we do not need to wait on some silver bullet new technology. What we do need to do is to get busy using the solutions that we already have. For more information and inspiration, you can Google Project Drawdown List and learn about these. And now to put on my economist hat, I always ask audiences to raise your hand if you took an economics class. So please raise your hand if you took an economics class. And now raise it again if it was your favorite class. I saw that. So basic economics, one of the lessons in the basic economics that you took is that when it is free to pollute, we get too much pollution. And we cannot rely on enough individuals and firms opting to cut their pollution. So here's a picture that somebody in the Wednesday crowd recognized to have been the Cuyahoga River burning in 1969. There was so much trash, runoff, waste that had found its way into that river that it literally caught fire, and not just once. And that helped prompt the 1972 Clean Water Act. And this city, Los Angeles, made the cover of Life in 1954 for having such polluted air. And that helped prompt the Clean Air Act. So all economics texts teach that if we want clean air and clean water, we've got to have a role for government. Likewise, if we want folks to quit using the atmosphere as a dump site for greenhouse gas emissions, we need government to play a role. I imagine you aren't surprised to hear that economists tend to prefer markets and financial incentives over regulations. And so we recommend this approach to cutting emissions in our economist statement on carbon dividends. This statement was signed by 27 Nobel laureates and me and 3,600 other US economists. And it calls for, so our approach, the economist approach to climate policy is a gradually increasing carbon fee or carbon tax. So this is one type of what we call carbon pricing. That is, make polluters pay to pollute. Don't let polluting be free. Make polluters pay to pollute and we will get less pollution. So by the economist plan, this creates a market incentive to phase out of fossil fuels. It makes polluting more expensive. So we got a financial incentive to phase out of fossil fuels. And we recommend taking the revenue that the government collects and returning it to Americans via equal lump sum rebates. The majority of American families will benefit financially because they will get more in those rebates in the carbon dividends than we pay in increased energy prices. And this is especially true for low-income people. So it's slanted in that way for low-income people to take care of them as they face the increased prices in energy. And it also, our plan also has a border adjustment to protect American competitiveness. That's important. A bill along these lines has been introduced in Washington. Yay. And I usually spend about 10 minutes talking with people through this bill, but time does not allow in this presentation. There it is. And back in 2003, Senator McCain sponsored a carbon pricing bill. So carbon pricing, making polluters pay, is the preferred economist way of dealing with it. And Senator McCain also liked it. So concluding now, don't worry, be active. People often ask me if I have hope, and hope is what we create when we work together. So yep, I'm not alone in this, and I ask you to join us And here are 3 specific actions for you to take. The Citizens Climate Lobby, or CCL, is the primary organization that I have worked with, volunteered with over the last 7 years. Here we were pre-pandemic, and our June lobby day, after the picture, we spent the day in over 500 congressional offices, speaking sometimes with members of Congress, sometimes with their staffers. This is what lobbying looks like in the Zoom during the pandemic. That's my congressman on the lower right. The CCL is divided into chapters. There are 4 chapters in Alabama. Huntsville does not have one, but one of these is an at-large chapter. So please go to the Citizens Climate Lobby and website and find out about how to join us. Our core values in the CCL is we're building relationships, even with people who disagree with us. We are fiercely nonpartisan because we want legislation passed, and we know that's going to take people from both sides of the aisle, and we're sort of relentlessly optimistic about it. We advocate for market-based solutions. So that Energy Innovation Carbon Dividend Act, the carbon fee and dividend, the economist position has been our primary ask when we go into meetings. I personally am going to be arranging the lobbying of Senator Tuberville's office early in the summer and would love for you to join the team. So Google Citizens Climate Lobby, find out how to connect with us and get a little bit of training, lobby training, and join the team. The third act is a new organization with co-founder Bill McKibben, for those who might recognize his name. We are aiming to bug the banks. Big banks play a key role in propping up the oil and gas industry. So please sign the Banking on Our Future pledge to move big banks out of fossil fuel investments. Our targets are Bank of America, Chase, Citibank, and Wells Fargo. And here's the gist of what you would pledge. If by year's end, my bank is still funding fossil fuel projects, I pledge to close my account and cut up my credit card. If I don't bank at these institutions now, I pledge I won't. So don't switch your bank just yet. We're collecting pledges, I think, over this year. And the bigger the number, the bigger the impact. Also, when it comes time to cut up your credit card, if your bank hasn't isn't out of fossil fuels, the third act will have guidance and suggestions for how to make the switch to another bank easier. So please go to the third act and make the pledge. The third main thing is you can, for $5 a month, you can power your home with clean and renewable energy without changing your electric utility. So basically with Arcadia, what you'd be doing is funneling part of your monthly electric bill to support and expand green energy. And you can learn more about that at the Arcadia site. So again, Citizens Climate Lobby, you can personally lobby, volunteer to lobby DC for fair market-based climate policies. At third act, you can take the banking pledge, and with Arcadia, you can get you can support clean energy on a monthly basis. Other things you can do is contact your elected officials, please. Write letters to the editor. I'm hearing more and more newspapers don't accept those or don't publish them, but if you've got access to a newspaper that publishes letters, please write. Talk about climate change. The data show that people who are concerned about climate change aren't talking about it with their neighbors and friends and family. So talk about climate change. I'm happy for you to get me a speaking gig after having made the trip to Huntsville. I'm less excited about driving back up there, but be in touch if you need a speaker. And also I'm hoping that you'll be allowed to share this presentation with friends and family and neighbors if if you think that would be a way to prompt some discussion. And then of course, there's all those lifestyle choices. Eat a plant-based diet, don't waste food, compost, avoid shopping, which is good for us in many ways, drive less, have a fuel efficient car, and fly less. Oh, and recycle. So lots of things that you can do. This is true, you know it, you've seen it in your lives. So things do change, shift happens. Please, please be active. So, hello. I think you're seeing my techie person there. So everybody, I really appreciate you being here. I hope that this worked for you. I do better with a live audience, but there it is. So thank you for your interest and for anything you can do to help us get a handle on this. Bye-bye from Birmingham.